Okay, good afternoon. Next, we're going to see the presentation on search algorithm of the subject of artificial intelligence. Okay, next. Problem solving. Problem solving is one of the basic processes of reasoning that artificial intelligence needs to approach. Reasoning that artificial intelligence tries to approach. The goal is to get an agent to find a solution a given problem in a way that is comparable or superior to how a human would do it. For example, we had an agent problem solver that their main characteristic that they look for a sequence of action that lead to several states to do so. It shows an objective that sits the sequence of action that lead to for an initial state to some target state. An initial state to some objective stage in order to be able to solve a search problem if it is necessary to perform the following steps. Okay, first steps. The first one is the formulation of the objective. This step consists on setting the goal to be pursued based on the current situation and the performance measures of the company. And second one is the problem formulation. After we do the first step, the next step is to decide which action and state had to be considered to be done. The third one, search. This process consists of the strategy that examines different possible sequences of action to find the possible sequence of action to find the one that leads us to the pursuit objective. And finally, we have the execution, the set of actions recommended by the solution that are carried out. Uninformed searchers. This type of strategy does not rely on a problem sound information to solve it. They base the search on the structure of the state space and apply systematic strategies for its exploration. They are exhaustive algorithms that, in the worst case, go through all the nodes and find the solution. Uh, Wide search. This kind of search tries to look for level by level. Uh, let's say that the top of this node is A, and B, C, D, A. The wide search tries consists to look for all the nodes in the same level, and after we go to the next child. For example, we start in this node, right? After that, we go to the node B, or this one as you want to call it, but we don't. We are not going to go to this node. Just we're going to go the next one. That it would be this one, and it's going to be the same for the same next iteration, the next one in the same level. Yes, entonces once we were here, we have seen all the nodes in this level. We can go to the next node in this level. Right, it would be this and this and this and this and this, and that's the purpose of the wide search. Okay, we had the greedy algorithm. It is a heuristic or approximate algorithm that selects the next node based on the immediate codes. This locally optimal decision usually directs the search for optimal solutions from the point of view of the implementation. You can order a sequence of nodes to be tested using a priority queue. Okay, now we have the NAT stack problem. Uh, Commonly referred to NATS problem is a combinatorial optimization problem, one that seeks the best solution among a finite set of possible solutions to a problem. Uh, Consists and that we had n rational of objects and a backpack. Object I has a weight of p sub e 1 minus equal e minus equal n. The backpack has a capacity c. If if you enter a fraction, it should e 0 minus equal it should e minus equal 1 the logic in the backpack, then I get eight benefits. The object is to fill the backpack with a way to maximize profit total. But as the backpack has the capacity to see the total weight of the all objects stored, it can get over the amount. Um, we had here a 15 kilos weight total, right? And we had some components that has 2 kilos for $2, 1 kilo for $1, 1 kilo for $2, 12 kilos for $4. So uh, the problem consists to fit all the most things to get the most benefit to fit in this backpack, right? And we can fractional this object to get the best solution possible. For example, if I had only put in the backpack 6 kilos, that it would be the half of this. The I only would have or get $2, right? And it's the same to all the objects. Okay, so we had a set of candidates that are objects taken from the certain fraction, right? The selection function is the most difficult to determine. If we proceed greedily at each step, we must consider an object and take a certain fraction of it. A set of candidates is completable if the sum of their weights does not exceed the capacity of the backpack. It is if a solution if E equals a capacity. The objective function to be maximized is this one. Okay, yes, the explanation of the greedy algorithm is we have to follow a queue to determine what kind of or what node is the next one, right? So we the first thing that we have to do is define what is the chosen to select the best candidate. We take everything we can from him, right? So the second strategy is choose the item that fills the backpack less to accumulate benefits from a greater number of items. However, an item with little benefit may be chosen simply because it weighs little, but we could get uh, less profit on it. The third strategy, which is optimal, is to always to take the object that provides the greatest benefit per unit of weight. So this tries to explain that if we in the second strategy we could took the only the element that has the lowest weight and put it in the backpack, but it's not always going to guarantee that we are going to get the math of the profit. So the third sequence says that if we can only get the first of all the heaviest object to get the max profit be able. So that's all. Thank you.